For our next example, we are going to use this graph to find, again, a delta greater than 0, such that absolute value of x minus c less than delta implies that absolute value of f of x minus L is less than epsilon. And again, we've been given some information here. We've been given our function. This is a square root of x curve here. We've been given our c value to focus on. So here, right here, c equals 1. Okay, I think I was denoting that in blue. C equals 1. We've been given our limit value. Okay, L equals 1. That's right here. Notice how that truly is the limit value for this function and this value of c. That's the limit as x approaches c, which is 1, and our function is square root of x. Direct substitution on that tells us that, yeah, okay, limit is 1. So L equals 1, check. Okay, and then we're also given an epsilon value of 1/9. So notice again that our interval marked off here has an upper boundary of L plus epsilon and a lower boundary of L minus epsilon. Okay, this little distance in here between the center L and either side of the boundary is epsilon in there. So 1/9 in either direction. Okay, so we want to figure out the corresponding distance delta along the x direction. Okay, so let's go down here and take a look at our edges of the boundary. So here on the upper side, we have 100/81. Okay, so that we might say is c plus delta. Okay, and if we did that and we know that c equals 1, that would tell us that delta equals 100/81 minus c. So 100/81 minus 1. Okay, 81/81. We would end up getting 19/81 there. Okay, I'll just make you a little note, c equals 1, that's why I wrote it that way. Okay, so that looks like it would be our delta. Then if we go over here, c minus delta, maybe? Okay, spoilers, this isn't gonna quite work out the way we wanted. So c minus delta, if we use this delta over here of 19/81, okay, 1 minus 19/81 would be, okay, 81/81 minus 19/81. Okay, that would be 62/81. Okay, and we can see that, okay, that is not that value right there. So 62/81 would be like here. Uh-oh. So, nope. Okay, so notice how, in this case, we get the 62/81. That actually lies outside of the interval that we want. Notice how this interval along the x-axis is marked off based on the L plus epsilon and L minus epsilon values, okay? This is the lowest that interval will go, L minus epsilon being 8/9. That corresponds to an x value of 64/81. So this is the lowest x value we could have. Okay, 62 over 81 falls outside that interval, so we actually wouldn't be able to use that and still fall within the right interval of y values. See, we slip out of the interval underneath there. Okay, it's less than 8/9. So that's not so good. So we need to take a different tactic here. Turns out the delta, quote, quote, that we found over here on this side, the 19 over 81, that was a potential option for delta. We could have also calculated delta by starting over on this side. Okay, so I'm going to do this one in orange. Let's say that 64 over 81 is C minus delta. 64 over 81. And now we're going to calculate delta based on that instead. All right, so delta would be, let's see, move some terms around. It would be C minus 64 over 81. And then C equals 1 still. Okay, C equals 1. And so we would do 81 over 81 minus 64 over 81. And we will get, that looks like 17 over 81. Okay, so that's the next delta we'll kind of check in on. Okay, so let's see. Let's make sure that this will allow us to still fall within the proper interval over here on the right side of C. Okay, C plus this delta would equal 1 plus 17 over 81. And so let's check that out. Crunch the numbers. Okay, that would be 98 over 81. And you'll notice that this is actually okay. 98 over 81 would fall right here, approximately, and that is within the specified interval. If we use that value, 98 over 81, for x, it will still give us a fine y value that falls within epsilon of the limit. Okay, so this is okay. Okay, because it still falls within the interval. Okay, whereas our previous delta, the one that was like, nope, that did not work because this value is outside the interval. Okay, and we don't want that. So that means if we have to choose between these two different delta values, 19 over 81 versus 17 over 81, we're going to pick to go with that smaller one, 17 over 81, because it was okay and allowed our values to still fall within the specified interval. We were close enough to C equals 1 on both sides. And those values led us to y values that were close enough to our limit L. Okay, so that means our answer here would be to choose the proper delta, the smaller one, delta equals 17 over 81. Okay. And so for a note in general on this problem, all right, note. If you see a graph that is asymmetrical in the interval like we had here, this was a little smaller to one side than the other, okay? So if you see an asymmetrical graph, if the graph is asymmetrical, ooh, squeeze that in there, choose the smaller delta value. That will always guarantee that you, it's like a safer choice there. It will guarantee that you fall within the proper interval because it's playing it a little safe. Choosing a smaller interval along here guarantees us a more, it's like a more conservative result there, like playing it safe. Okay, so there's our note that applies to this problem.